Bayesian inference is just like a general, almost philosophical framework for reasoning about uncertainty. So you have some latent quantities, call them parameters, and you want to do inference on them. Like, you want to know what these latent quantities are, but all you have are actual observables. With Bayesian neural networks, for instance, these parameters would be the neural network weights. And so you want full Bayesian inference on the neural network weights. So that's one approach of doing like Bayesian deep learning, but that's not what I'm currently doing. Instead, we have like a normal Bayesian model, which has statistical parameters. So you can imagine it like a mechanistical simulation program. And we want to estimate these scientific parameters. So for example, if you have a cognitive decision-making task from the cognitive sciences, then these parameters might be something like the non-decision time, some information uptake rate, some bias, and all these things that researchers are actually interested in. And usually you would then formulate your model in, for example, PyMC or STAN, and then run MCMC for parameter inference. And now where the neural networks come in my research is that we replace MCMC with a neural network. So we still have our Bayesian model, but we don't use MCMC for posterior inference, but instead we use a neural network just for posterior inference. And this neural network is trained via maximum likelihood. So the neural network itself, like the weights there, are not probabilistic. There are no posterior distributions over the weights, but we just want to somehow model the actual posterior distributions of our statistical model parameters using a neural network.